Hello everyone, in Chapter 6, we are going to study human populations, which is a very popular topic in environmental science. And this is the chapter outline. And after we study this chapter, you'll be competent in doing the following things. And my focus will be demographic transition. So, what is birth, death rates? And that is easy to understand. That is per unit of population, how many people died and how many people were born. So, needless to say, the higher the birth rates are, the lower the death rates are, the larger the population size are. For example, in Costa Rica, the birth rates is 16 plus and the death rates is -4. So there's 12 per 1,000 were born each year, and the total population increase is about 6%. And in the United States, the population increase is lower because the death rates are higher and the birth rates are lower. And in Hungary, the death rates is even larger than the birth rates. So the total population is shrinking. This is the typical population growth curve. And there's 4 phases. The first one is lag phase. So that is very slow increase, very small, with a very small size of population. And as time goes by, it will go into the accelerated growth. It's exponential growth. And then because of the limiting factors, the growth cannot go forever. So the whole population enters into a deceleration phase. So the growth is slowing down. And finally, it reached the stable equilibrium. The stable equilibrium means the death rates and the birth rates are almost the same. So the size of population is stable. And it doesn't mean the population is crashing or people are dying. It just reached the stable size of the population. And these are the important concepts for you to study, to review. And understanding the population growth curve is very important to understand the behavior of a population, the increase and decrease of the size of the population. So the first goal we are going to reach is the history of human population growth. So we are going to have an idea how the population is growing globally. And I like this graph so much because if you look at the left side, that was a long time ago when human appeared on Earth, and this is a time close to when we are living today. So you can see this curve is pretty flat in the past thousands, even millions of years. And it has a spike. Let's see what time is this. This is almost, see, this is 1,000, this is 2,000, this is about 1,800. And the industry evolution is causing this spike. You probably wonder why. It's because of the health condition improvement, because of the technology, and the wealth was increasing. So the living condition greatly improved. So the health conditions were improved and the death rates are greatly down. That's the reason we have a rapid growth. It looks like exponential growth of the whole population around between 1800 and 1900. So to summarize, the human population growth curve has a long lag phase, followed by a sharply rising exponential growth. And the major reason is an increase in Medicare and a consequential decrease in death rates. And now over 7.6 billion people live on Earth. And many people probably wonder, do we have too many people? How do we support the growth of the population? And for some generations, they experienced the doubling or tripling of the population. And you can look back and find where you live and how much the population grew since you were born. And in 1798, Thomas Malthus, this person is, I would say, a pioneer demographer, and he predicted if the population keeps growing like this, eventually the population will crash, and we're probably going through a phase called extermination. And what his prediction led to was not what happened really in this world. And we did not go into extinction because of the crash, largely due to the technology advances. And demographers, they are social scientists who study the characteristics and the consequences of human population growth. So those scientists study populations. And environmental scientists work with demographers to study environmental trade-offs of increased wealth and consumption that are going along with changing populations. And looking back in history, I'm not going into the details of every crashed population, but long story short, disasters like famine, plague, that can cause human population crash. And also climate change and overexploitation of the resources can also lead to the crashing of the human populations. The 50-year drought, imagine that. Even a couple of years, that is horrible enough. And so eventually those Mexican people, those people live in New Mexico, they abandoned their living area because nothing could grow. And the example on figure 6.3, that's an example of overgrazing, and eventually the land was completely diverted to, I wouldn't say desert, but it's not supporting any growth of the crops. So the people have to abandon the land, and there's no population on the land anymore. Another person, biologist Powell, in 1948, predicted humans have already met Earth's carrying capacity. That was about 70 years ago. And he predicted majority of the human will be wiped out. And neither of these predictions really came true, again, due to the technology advances. But that doesn't mean we do not have challenges and limitations. There are natural limits. So here on this slide, I'm going to introduce a few concepts. One is total fertility rate. That determines the average number of children a woman would have in her reproductive years. So that's all the children she has. And the TFR of 2.1 is known as a replacement fertility. Why it's 2.1? Imagine a husband and a wife have one child, okay, and after both of them died, the child can only replace one of them. So we need at least 2 children to replace both parents. Why it's a little bit higher than 2.0? It's because not all the children survive. So don't ask me how to calculate the model or the equations. But statistically, a TFR of 2.1 is set as replacement fertility. It's pretty accurate. And if we look at the graph on the right side, the brighter the color, the higher the TFR. So about, let's see, about 50 years ago, some area of the world has really high TFR. So a lady will have like 5 to 6 children or even more. And now this is like after like 40 years later, and the TFR greatly dropped even in those hotspots. So what did that tell us? The population, the global population are going to increase or decrease. We're getting stable. We'll get there. So overall, United States and other developed countries is below, the TFR is below 2. And China and Japan even lower, with a TFR of 1.5 and 1.3. That will lead the aging of the populations, and we're going to talk about that later. And the TFR in some developing countries are still very high. And like some countries in Africa, that means they will have rapid growth of populations. So what has driven recent population growth? The declines in the death rate. That's the first reason. And medical and human health advances that lead to the decrease of the death rate. So that this is kind of repeating my message compared to the beginning. We just talked about those early demographers. They predicted that we will have a human population crash, or we will go into extinction because we have too many people, and that those phenomena did not happen because we have advanced technologies. So in the ancient time, we need 100 hectares to support one person. And nowadays, we only need 0.2 hectares. And that's 500-fold difference. And in the future, pretty soon, it will drop to 0.1 hectare. So how much human activity can Earth support? Well, we touched the concept of carrying capacity again. This is the maximum number of individuals of a species that a habitat can sustainably support. So we can, to imagine the human population as a whole, all the human populations on the Earth, and we only have one Earth. So sooner or later, the Earth, which is our habitat, will reach the carrying capacity. And as to how big the human population will be, and nobody knows for sure yet. But we know we are reaching the carrying capacity sooner or later. And although we can expand our carrying capacity, we also produce a lot of negative consequences, such as pollutions and climate change. And that makes the conditions, the environments on the Earth much worse. And that will limit the human population also. If all people on Earth will live like United States, like the people in the United States, it will take more than 4 Earths to provide the resources. So we can imagine that people living in other areas of the world will have much less resources than us in this country. So this concludes my first part of the lecture.